Hi there. My name is Kirsten Hannam, and I'm a research scientist with Agriculture and Agri-Food Canada. I work at the Summerland Research and Development Centre along with my colleague Jessie McDonald. The slides I'm going to show you here were prepared by us for the Feeling the Heat Symposium, but we cut this presentation out in the interest of time. We decided to record it and make it available to you now so you get the benefit of the slides that we pulled together. The figure on the left was drawn from the long-term temperature record collected at the Summerland Research and Development Centre. It shows that the number of days greater than 35 degrees Celsius has been increasing in frequency, particularly over the last couple decades. This trend seems to reinforce what we heard from our colleague Farron Anslow, who opened the symposium. His modeling work suggests that heat events like we saw this summer are going to become more frequent in the coming decades. This reinforces for us the need to develop a weather extremes toolkit. For the fruit tree sector, such a toolkit could include longer term solutions such as the use of more resilient rootstocks or varieties, altering the training systems that we use, even altering the orientation of the orchards that we plant in the future. But we also need shorter term tools that can be deployed now to help protect the fruit that we're growing in the next few years. These tools could include things like evaporative cooling, depending on your irrigation system and water availability. It could include things like shade netting, or simplest of all, the use of foliar protectants. And we heard about a whole suite of different types of foliar protectants during the Feeling the Heat Symposium. But in 2021, Jessie McDonald and I had the opportunity to test out a locally produced calcium carbonate based foliar protectant. We tested the utility of this foliar protectant in a 20-year-old Fuji block on M9 rootstock. It was a little orchard. It only had 5 rows, and we used each of these rows as a replicate. We divided the rows in half and randomly applied the foliar spray treatment to half of the trees in each of these rows. Jesse was the lucky guy to apply the foliar spray. He used just a basic backpack sprayer, and he applied the foliar spray 3 times. First, when the fruit was about 1 to 2 millimeters in diameter, so at fruit set. About 4 weeks later, when the fruit had reached 4 to 5 centimeters in diameter, and then again about 4 weeks later. The figure that you see at the bottom right of the slide was generated by Farmwest. Farmwest is a website that provides decision supports tools to a whole suite of agricultural sectors in British Columbia. This figure shows the daily maximum and minimum temperatures from the 1st of June until the end of August. And I've placed blue stars on the dates when the foliar spray treatments were applied. So you can see that the second foliar spray was applied just as the heat dome was starting to form. The peak of the heat dome is indicated by that orange arrow. We were interested in understanding how this foliar spray treatment might affect tree water status. So we periodically measured stem water potential. We also monitor changes in transpiration rates, stomatoconductance, and photosynthesis. And as well, at harvest, we measured a whole host of fruit quality parameters. It was really interesting to see that the foliar spray treatment had no significant effects on fruit height, diameter, and weight. It also didn't affect things like soluble solids, titratable acidity, or dry matter. There were pretty strong trends of a decrease in water stress and also a slower rate of photosynthesis with foliar spray application. But the treatments weren't statistically significant, and it didn't translate into changes in the fruit biomass accumulation. Of course, we were particularly interested in how the foliar spray affected sunburn damage in this fruit, and this was definitely the year to test that. We used a modified version of the Schrader-McPherson system to evaluate sunburn, and we divided the sampled apples into 3 classes of sunburn. Zero sunburn, which is indicated by no symptoms of sunburn at all. Minor sunburn, which would be characterized by the apple that you can see just above the number 1 in the figure on the left. And then we compressed all the other severities of sunburn into a final major sunburn class. And we found that spray application did indeed increase the proportion of apples that showed no sunburn symptoms by 9%. It had no effect on minor sunburn incidents, but it also did reduce the frequency of major sunburn by 9%. We also know that heat damage can increase the severity of asymmetry in fruit. And interestingly, we found that spray applications reduced the frequency of asymmetry by 10%. So this little pre-trial experiment, which happened to occur on the most severe heat and drought summer that we've ever experienced, showed that foliar spray can indeed cause or can indeed be used as a tool to decrease the frequency and severity of sunburn damage in apple. I'd like to close by thanking all the technical support we received from Sean Kuchta, Sebastian Damon, and Laura Holt this summer, as well as support from the BC Fruit Growers Association and the Okanagan Horticulture Advisors Group for this symposium itself. Thanks.